All right, welcome to section 8.1.2. We're going to be investigating properties of logs in this section. So first thing we're going to do is start off, it says convert the following equations to exponential form. Then solve for x algebraically. So first thing we're going to do that circle dance. And now we get 2 to the x equals 30. Now to get the x out of the exponent, I would have to take the log of both sides. And I move that x out in front using the power property. And then to get the x by itself, it's now a multiplication problem, so I'm going to divide by log of 2. So in my calculator, I'll type log of 30 divided by log of 2. And I end up with 4.9069. All right, same idea with part B. I'd have 5 to the x equals 200. I'll take the log of both sides. And then I'm going to use the power property, move that x in front. So I have x times log of 5 equals log of 200. And to get the x by itself, we're going to divide by log of 5. So if I type log of 200 divided by log of 5, I get 3.292. And in general, if I just have these letters here and converted this, I'd have a to the x equals b. To get the x by itself, I would take the log of both sides, use the power property to get that x in front, and then I'm dividing by log of a. So in general, each time I do this, I would say x is equal to log of b divided by log of a. So ultimately, we're just taking log of, we're getting the x by itself by taking log of whatever in the parentheses and dividing by log of the base. Same thing holding. Here we did log of, our final answer was log of 200 divided by log of 5. It was log of what was in the parentheses divided by log of the base. Here we did log of 30 divided by log of 2 to get our final answer. It was log of what was in the parentheses divided by log of the base. All right, we also are going to look into changing the base, how we can change the base of a log. So this one says change log base 9 of 4 into a base of 3. So right now it's a base of 9. We want to turn it, how do I make it a base of 3? And to do that, what you're going to do is write your log expression and just put equals x. We're then going to convert it similar to how we did it above. So I'd have 9 to the x equals 4. And for all these, we just took the log of both sides. And remember, that would be a log of 10, log base 10. But we could really have taken log of any base. Doesn't matter. Base 10 is just the easiest on our calculator. So if we want it to be a base of 3, guess what? What I'm going to do right here is I'm going to take log base 3 of both sides. And so, when I take log base 3, I can still use my power property. And now I have x times log base 3 of 9 equals log base 3 of 4. And to get the x totally by itself, I would divide both sides by log base 3 of 9. And so my final answer would be log base 3 of 4 divided by log base 3 of 9. Seems kind of strange, but now our base is a log with a base of 3, but that's how you would do it. So go ahead and try A and B on your own. All right, some other properties of logs. Since logs and exponentials are inverses, the properties of exponents, which we already know, translate to logs. The problems below will help you discover these new properties. So for part A, it says complete the exponent rules. In parts B and C, you will find the equivalent properties of logs. So remember, if I have x to the a times x to the b, I can make that a single base and add your exponents, x to the a plus b power. And if I'm dividing the same bases, x to the a divided by x to the b, I can make that in a single base by subtracting my exponents, x to the a minus b power. All right, so what we're going to do now, it says to find the equivalent log properties, use your calculator to solve for x in each problem below. Note that x is a whole number in parts I through v. So what we're going to do is we're going to use our calculator and approximate where we're at here. So log of 5 is equal to 0.699. And then log of 6 is 0.778. That's equal to log of x. When I add 0.699 plus 0.778, that gives me 1.477. So I would end up with log, and again, that's a base of 10 of x equals 1.477. And when I convert that, I would get 10 to the 1.477 equals x. So 10 to the 1.477 power. And I get 29.99. And again, just because of rounding issues, it does tell us that all of our answers are going to be whole numbers. So we get x equals 30. If I would have taken this out to longer decimals, I would get exactly 30. I'll do one more. All right. So I have log of 5. So log of 5 again is 0.699 plus log of 2, which is 0.301. And that's equal to log of x. So when I add 0.699 plus 0.301, I get 1. So I end up with log of x, and again, that's a base of 10, is equal to 1. And when I convert that, I end up with 10 to the first equals x. So x is equal to 10. All right, I want you to try and do the other 3 on your, these other 4 on your own. All right, as you go to number 3, you should end up seeing that x is equal to 25. As you go to number 4, you would see x is equal to 1,000. And as you get to v, x is equal to 99. So if you notice, there is a pattern here. Anytime we're doing this, we can make these logs that are being added into a single log by multiplying what is in the parentheses. 9 times 11 is 99, so log of 99 is what we had here. 10 times 100 is 1,000, log of 1,000. So this answer here would be log of A times B. A times B. All right, as you go to the next page, it says, what if the log expressions are now being subtracted instead of added? Solve for x in each problem. Note x is a whole number again for I through v. So again, I'll do a couple examples. If I do log of 20, I get 1.301 minus log of 5 is 0.699. That's equal to log of x. So when I add them together, again, it'd be log base 10 of x equals, I'm going to subtract 1.301 minus 0.699. I get 0.602. So when I convert that, 10 to the 0.602 equals x, or x is equal to 3.99. Again, we're rounding to the nearest whole number, 4. I'll do 2 with you guys as well. So log of 30 is 1.477 minus log of 3, 0.477. That's equal to log of x. So again, this is log base 10 of x equals, when I do that subtraction, I get 1. So I get 10 to the first equals x, or x equals 10. Go ahead and try doing the other 4. So for 3, you should end up with x equals 5 halves, or 2.5. For 4, you should end up with x equals 17/9. Leave it as a fraction. And then for the last one, you should end up with x equals 375 over 17. Again, leave it as a fraction. So if you notice, what we're doing here is if we have 2 logs that are being subtracted, we can make that into a single log by dividing the number that are in the parentheses. So here we had log of 5 minus log of 20, and that was equal to log of 4. So 20 divided by 5 is 4. 30 divided by 3 is 10, so that was log of 10. Here, log of 17 minus log of 9 was equal to log of 17/9. So log of A minus log of B is equal to log of A divided by B. And so we have a few properties here that we want to go over now. In our properties, the first one is the power property, which we learned last section. The power property says that if I have log base B of A to the x, that is equal to the same as x times, moving that exponent out in front and multiply it by whatever remains now, log base B of A. We also have the product property, which says log base B of A plus log base B, we'll say, of C. We can make those 2 separate logs that are being added together with the same base into a single log by doing log base B, so it has to be the same B, and multiply those exponents. Log base B of A times C. The quotient property is where if I am subtracting 2 separate logs with the same base, so log base B of A minus log base B of C, I can make those two separate logs that are being subtracted into a single log by writing it as log base b of a divided by c. Our definition of logs, remember, if I have log base b of a equals x, that is the same or equivalent, using the circle dance, to b to the x equals a. And then our inverse, this was a property we kind of saw in our study guide. If I have a log and an exponent of the same base, they cancel each other out. So if I had, let's say, base of b, and in the exponent, I had log that same base in it, those base and the log cancel out, and it's left with just a. Similar, if I have a log with a base of b, and in that log, I have that same base being raised to a power, that is just equal to, those bases again cancel out, equals x here. And those are our 5 properties. We'll be working more with them coming up.